Okay.
Yeah, no worries. I mean, as I mentioned, computers suck, so this is all par for the course. So if we remember the diagram before, there's basically one central point where stuff can fail and kind of crash the whole system, and that's your server. Whereas in a decentralized or peer-to-peer network, there's a whole bunch of other avenues that can be followed to get some data. And this makes it more resilient. So for instance, I can load a website on my device, and if somebody is looking for that website's data and they're on the same Wi-Fi network as me, and we don't have an internet connection, they can still load that website directly from me rather than having to worry about like coming back online. In fact, a lot of traffic can be more local without having to go all the way out to like servers owned by Amazon, and like having all of our software basically like making sure Jeff Bezos can catch up with Bill Gates in the billions. Anyway, so that tangent aside, let's talk about that. So it's kind of the protocol I've been working with a bunch. Nina and Alex as well have been playing around with it. And it's kind of the protocol, a protocol that makes it easy to make these peer-to-peer systems, or use these peer-to-peer networks to make applications. So before I do anything else, I'm going to quickly do a demo. So live demo time. Hopefully it works. I'm going to quickly, hello again, long time no see. I'm going to share my screen.
Send me the link. It's in the Facebook WizardAmigos group.
So I'm going to scale up my text, so hopefully you can see anything. And so what we're going to do is create a peer-to-peer website live. Can y'all read the text on my terminal here?
We can see it great.
All right. So what I'm going to do is create a new website. So I'm going to make a directory, my website. And then I'm going to create kind of like a landing page for it. So,
What it is.
So we need a doc type just because, where are y'all in right now? Was it Taiwan or Thailand?
Thailand.
Thailand.
Thailand. Awesome. I'm very bad with geography, so sorry for mixing it up. Anyway, so let's say give it a title. Wow, we can do YouTube stuff. So I just created a web page. So let's turn this into a website. So that, the easiest way to use it, kind of, I guess debatable, is to use the command line application. And so you install it either downloading a binary or using Node.js and NPM. And then it lets you do all sorts of operations with that. So what I'm going to do is I'm going to turn my current folder into a website. So I'm just going to enter some trash for the title and description. And bam, now we have a .dat URL. So this link here is a public key from a public-private key pair. And this is how you actually discover content in the peer-to-peer network. Every archive has a unique link. And if you send a link to one of your friends, they can discover your computer and download data directly from it. So if I want to start sharing the data in this website, I just type that share. And then it's going to process the files and start waiting for peers. So now if I take that same link and open up a new terminal,
Could you paste the link to the chat?
pardon me?
Could you paste the link into the chat somewhere? So we could try to.
Which
Maybe in Jitsi, and then I can share it with the.
Yeah, then you can. We can try to.
I just posted it in the .irc, so maybe that'll be useful. Is that good?
Yeah, we'll try. Just continue. It's all fine. Thanks.
Awesome. So we'll see if you can get into my local computer. But in the meantime, what I'll do is I'll simulate somebody downloading the archive. So to download a DATS, I just do dat upload and then paste the URL. And then what it'll do is you probably missed it, but for a split second, it said the upload was 93 bytes per second, or bits per second. I don't know which one that is. And it quickly loaded the file. So if I go to this directory, you can see there's that index HTML with the contents that I expected. And now if I want to reshare this archive from this new peer, I can just do a dat sync, and this will now start resharing the file. So if you see here in my original terminal, I have one connection, and here I have one connection. So these two peers are now connected to each other, and they're both resharing the archive data on the peer-to-peer network. So in addition to using the command line for sharing archives, we've got some useful apps. The most popular one being the Beaker browser. So this is a web browser based on Chromium and Electron. And it's essentially bundles the apps into the browser so that we can load it, DAT archives the way we would to any other website. So I just pasted the DAT URL, and bam, it loaded it up really quick. You probably didn't even see any network traffic in the sidebar. And so if we look here, there's two peers. There's my first terminal, my second terminal, and Beaker. So yeah, there we go. We just did a peer-to-peer website. One cool thing about Beaker is they have this live reload, and I'll demo that by going in and modifying the website and having it reload live. So I think this is the way to do it. I see, what did I call it? It was my website, my dash website. And if I edit that index HTML, let's say make it a little cooler, a little bit more snazzy. If I save, bam. Basically, the DAT CLI detected the change. It pushed the change that propagated to all of the connected peers, including Beaker. And this live reload thing will reload the page every time it changes. So that's kind of fast, but this kind of shows the power of using DAT versus some other peer-to-peer protocols which don't have change propagation that's as fast. So this is kind of the gist of what DAT looks like in practice. Any questions about that before we move on to the internals of how DAT actually functions under the hood?
Oh, I was just going to ask about like naming and stuff. Is there any strategy for naming those really long public keys?
Do you mean like names that are human readable?
Yeah.
So at the moment, DAT actually lets you use regular DNS to create names for your archives. So the way that works is you take your archive URL and then you create a special DNS record in your DNS provider. Damn, y'all are having a rave there.
I just wanted to show you, Jonathan. Like, yeah.
Yeah, so could you try to explain that one more time?
Sorry.
Yeah, so basically, DNS is a way to kind of like hide IP addresses behind human readable names, and that kind of piggybacks on top of that. So what you do is you create a special DNS record using a TXT record type. And then basically what you say is, for this domain, this is the DAT archive that you would load. So then when Beaker tries to load, if you do DAT : / and then your website name, for instance, my blog is rangermove.hashbase.io. What the client will do is it'll actually resolve that rangermove.hashbase.io domain to a DAT URL and then load that DAT archive as if you entered the archive URL directly. So this is kind of handy for having human readable URLs, but I've been kind of on the fence about it because what this does is it introduces kind of centralization and requirements on the internet. Because say I'm in like post-apocalyptic wasteland, DNS doesn't work anymore because there's no internet, and someone shows me like a DNS-based URL, that URL doesn't work anymore because the infrastructure isn't there. Whereas the public key will work without having to worry about DNS existing. I mean, obviously that's kind of like an extreme use case. DNS works for most cases. And once you have once you have resolved a DNS name to a DAT archive URL, that is cached locally, at least in Beaker. So it's not the end of the world.
Can you do anything
Yeah,
about, can you do anything about Ethereum domain names?
Yeah, if Ethereum, if ENS wants to throw money at us to integrate ENS into DATs, I'm all for it. So yeah, if you're people that want to get rid of spare money to add ENS into DAT, like, you know, yeah.
I know that they have a lot of money, so who knows, maybe they actually are up for this. But one question, you said that like if you create that, you do that share. But if you are another peer that wants to also share, you just do that sync and then the address, or do you have to first clone it and then sync, or?
Yeah, so it's the last one. You need to clone the archive and then sync. So basically what sync does is it means pull all of the latest changes from the network. And then if you don't specify a flag to exit it once you've synced, it just kind of like stays online and reshares the data. Whereas what that share does is it looks at any changes that you might have made in the file system, and then it loads them into the archive and then starts resharing that data. So share basically detects updates that you created and shares them. Sync detects updates that have been created in the network and then loads them locally and then reshares what it has.
So if I want to set up many nodes myself, I share with one, and then if I have a server or something running on that server, I basically sync.
Yeah, exactly.
Okay, cool. Any more questions?
Unless you're going to talk about this in the next part, is there any sort of like stuff with Tor to sort of obscure the traffic?
Yeah. I was going to get into some of the networking stuff in more detail, but I wasn't going to get into Tor. But basically, at the moment, we're just using straight TCP UDP over IPv4, so it's not even IPv6. That means if, say, a malicious actor knows a DAT URL and wants to find people that have loaded and are sharing that DAT URL, they can't scrape the peer-to-peer network to find those people. Kind of sucks. We've been talking a bit to the folks from I2P, and they're interested in like helping us out to integrate I2P into our networking stack. I'm personally very interested in pushing that forward. Sadly, we're a little bit constrained on resources, so there's no one to work on it at the moment.
I mean, that's fair.
Again,
that's a fair strategy.
If there's like privacy-minded people that want to throw privacy into that, you know, I'm free to mentor anyone that's interested in taking it on and getting it integrated into the SDK, for example.
What is could you just help me out, what was the ITP thing that you're just talking about?
UTP.
UTP.
No, did I mention ITP?
So,
I2P.
Yes.
I2P for number 2.
okay.
Yeah, I2P is kind of like Tor, except they're not funded by the US government, and they're a little bit more decentralized, and they're a little bit less focused on mixed traffic that hits the regular ClearNet. So like Tor, I think a large use case is not so much the hidden services as it is connecting to those exit nodes to connect to the rest of the internet. Whereas I2P, they're really more focused on like hidden services. But at the end of the day, they're both mixed nets. So they basically, there's a swarm of I2P nodes, and then peers will kind of like route traffic through the swarms to obscure the origin and destination. Cool. So any other burning questions about the stuff I talked about so far?
Good to go further.
Awesome. Cool. So then I will hopefully load up my slides again and see if they work.
Yay, it's
Aha, they work.
Oh, okay, he doesn't have technical problems, it's only us. Oh,
There we go.
whoa. It's a little bit.
It either has delay or something is not working completely.
Wait.
Oh yeah, it says you're having connectivity
But maybe
issues.
we're having them.
Or maybe we are having them. You never know.
Is it visible?
No.
No,
Just no video.
there's no. We can still hear you.
All right, let me try relaunching my hello again. Long time no
Yes.
see.
Okay, see,
You are
I can see
visible,
you.
but the slide not. Let's see.
How's this?
Maybe it has a delay. I don't know.
Let's see.
No. Maybe you have to rejoin. Sometimes.
Yeah, sure.
Sometimes it happens. I don't know. Maybe it helps.
Okay, I'll be back in a sec.
All right. Exactly.
It's really.
Turn it on, turn it on. Oh, it works. Perfect. Hey!
Yay.
Magic!
Wow, I want this too.
Oh yeah, now it works. I can see it.
Okay,
Perfect.
so turning on
Alright.
off works.
Oh, cool. So this is how you fix computers.
Yeah, it's the old IT trick. Okay, cool. So now we've kind of seen how it works in terms of like, what does it look like? So now let's talk about how does the actual internals, how do the internals kind of look and how do they fit together? So DAT, much like many other peer-to-peer protocol, uses a peer-to-peer discovery layer as one of its lowest level pieces. So that's mostly based around this thing called a distributed hash table. So the problem in peer-to-peer networking is you have some sort of data and you want to find people that have the data. And in the past, what that really meant was having like a server keep track of who has what. So if you have a piece of data, you'll tell the server, hey, if someone wants this data, have them contact me at my IP address. And then later someone looking for the data will ask the server, hey, who has this data? And then they'll get back a list of IP addresses to contact. So that was kind of what was around in the earlier BitTorrent days. But since then, that's been replaced with this concept called the distributed hash table. So the idea is you have a key value store that's distributed across all of the peers in the network. So the keys in the key value store are identifiers for data you want to find, and the values are IP addresses. So in our case, in the case of DAT, what we do is we take a DAT URL, we hash it so that we can create a unique identifier which doesn't leak the original URL. And then we essentially advertise our IP address for that key on the distributed hash table. So I'm not going to go too much into how the distributed hash table works. It uses this algorithm called Kademlia to evenly distribute the data across the network and to reduce the number of hops it takes to actually find the peer in the network that has the data you want. It's computer science, boring. High level, the way it looks is a peer wants to advertise their IP address. So they publish that on the distributed hash table. Another peer wants to find the IP addresses, and it gets a list from the distributed hash table, and then that second peer will attempt to connect. The actual connection is done through a combination of UDP and UTP. Sorry, TCP and UTP. So TCP is just a way to get a bidirectional stream between two computers, and then UTP is basically the same thing except using a lower level protocol, UDP. So that's basically all there is to the networking. We advertise ourselves for given keys, we discover peers for those given keys, and then we'll attempt to connect to them and then start replicating data. Any questions about the peer-to-peer layer?
No. All
Awesome.
clear, kind of.
So wait, actually for the connection, UDP is supposed to be slower than TCP/IP, right? But it's about like data consistency where you get like the full communication. Is that right?
Yeah.
And then like
so basically, using UTP, there's really two reasons for it. One of them is that it drains fewer resources than TCP. So if you have a client which has like 100 TCP connections, that's really expensive and it'll drain resources from any other applications. So for instance, say I'm like streaming music and I have some sort of hungry TCP-based peer-to-peer clients, it's going to just kill all of the bandwidth from my streaming app, which kind of sucks. So since UTP is based on UDP, I can have a whole bunch of connections over a single UDP socket without having to kind of like drain more bandwidth from other applications. So that's kind of one side to it. The other side is that in some firewall configurations, it's easier to get UDP traffic through them. And there's some more tricks you can do for actually getting through home networks using UDP that are a lot harder with TCP. So that's kind of why we have both. If we can't get TCP, we'll use that. Otherwise, if we can get UTP, we'll use that. Otherwise, we'll cry.
So that's for the peer discovery, but is it also for the main communication afterwards?
It's for the main communication. The peer discovery is entirely UDP based. So the actual distributed hash table protocol is based on UDP. And that's because they want to make it more lightweight and reduce the overall number of connections that are established. So essentially you open a UDP socket just for the distributed hash table communication, and then you open a separate UDP socket for the actual peer-to-peer connection for replicating data. Sweet. All right, so last call on networking questions. Great. So once we've actually connected to a peer, the next step is the actual data that we're replicating with the other peer. So in the case of that, our fundamental building block is append-only logs. So append-only logs are a pretty basic data structure that's used a lot. So if you think of, say, the operation log in a database, or just linked lists in whatever sort of program, or even blockchains, those are all examples of this append-only log. So the idea is you have a series of events, and every time you have a new event, you kind of set it as the head, or like the root, or whatever the latest block, and then it points back to the previous version. And that's kind of the main thing that we communicate. So essentially, DATs take on append-only logs, does some fancy magic using this data structure called Merkle DAGs, so that we can efficiently compare two append-only logs between two peers and download subsets of them from other peers and verify them without having to download the entire log. So that's, again, more of a computer sciencey thing. I'm not going to get too much into it. But essentially what this means is when I connect to somebody, I know which section of the append-only log they have. I know what the latest changes are that I don't have that I might want. And I can efficiently download it from them or upload it to them when they ask for data from me. Yeah.
Maybe just one information at the end, it's mainly computer science people here. So I thought it's gonna be more beginners, but now I see that basically all are programmers somehow.
Nerds.
Nerds. All nerds. Okay.
Yeah. So it's actually pretty cool the way the Merkle DAG stuff works. Essentially, what we do is we have like a tree on top of the append-only log, and then every time you add another another item to the log, we kind of update that tree and create a new root, and then we use the private key from the DAT archive to sign that new root. And when you download a piece of data from your peer, what you get is you get the data itself, and then you get the subset of the tree that is kind of like relevant to that piece of data. And you get the signature of the root of that tree. So basically, we can download a subset of the data and then verify that it was in fact created by whoever created the DAT archive. So as well, the actual protocol that we speak, it includes a way to multiplex multiple append-only logs over a single connection. So if I connect to a peer, by default, I can have something like 256 logs being replicated with them. And as well, we use that DAT URL from earlier as an encryption key so that two peers connecting to each other can have an encrypted connection without a third party being able to man in the middle of them. So say you're a malicious actor and they're trying to capture your DAT traffic, they won't be able to know what data you're actually loading unless they know the DAT archive URL ahead of time. So any more questions about append-only logs or any questions about the append-only log stuff?
That's good.
Cool, perfect. So the append-only logs are kind of the lower level primitive to build higher level abstractions. So DATs, in terms of how you actually use that, it's all based around file systems. So you saw earlier I had that command prompt sharing files and turning them into a DAT archive. And then I loaded it in Beaker as a website, which is sort of like loading a file from a file system. And the way that works is we use two logs. We've got the content log and the metadata log. So whenever a writer or whenever someone who created the archive has new data, say example.txt, what they'll do is they'll take the contents of that file and stream it into the content log. So they'll open a stream for reading the file from the file system or wherever else, and then upload it to the content log as they're streaming it in. So they don't need to load the entire file in memory before they can add it to the log. So after they've uploaded the data to the content feed or the content log, what they do is they take the start index and the end index of where it is in the log, and they update a pointer for that file in the metadata log. So basically they say, if you want example.txt, start loading data from index 4 to index 20, because that's all the data. for this file. So after that, if a peer wants to load some data, what they'll do is they'll search through the metadata log and find what is the latest pointer for the file that I want, and then they'll start streaming the data from the content log. So basically, part of the cool parts of the lower level append-only log parts of DAT is that it's all based on streaming data. So you can say, oh, start streaming data from index 4 to index 20, and you can actually start loading data in your application as it comes in and processing it or whatever else without having to load the entire file in memory. This is kind of in contrast to some other systems where you need to download more data to actually verify the integrity, or you have more systems where streaming is a little bit harder to do. So this is a super useful feature. So the actual metadata is represented using a fancy data structure called a hash array mapped trie. I'm not a computer scientist, but basically what it means is that we have a sort of tree data structure, sort of like a file tree or a key value store with directories, and it's represented in this append-only log, and then we can kind of quickly traverse that log to just download those pieces that we need. So say we download the latest root, and we're like, oh, I want to find more information about files in the foobar folder. And then that data structure will tell you, oh, if you want to find out more, download block 13 in the metadata feed. And then you can quickly zero in on the data without having to download the entire data and build up some sort of index. So that's kind of the file system part. So all of this fits together where you have the networking kind of as its own separate ecosystem just for discovering peers and making connections. Then you have replication of append-only logs done on top of that. And then on top of that, you can actually have these file systems. And all of these layers are kind of separate, and you can mix and match pieces. I guess for the file system, you can't replace the append-only log too easily, but you can replace the networking pretty easily. And all of that is kind of abstracted away in the DAT SDK. So the SDK is a Node.js / just JavaScript model, which lets you and kind of use the file system abstraction. So it lets you create an archive, it lets you load archives, and it handles managing the storage and the networking for both Node.js and the browser. So I mentioned earlier how it uses distributed hash tables and UDP and TCP in Node.js. None of that exists in web browsers for security reasons. So in web browsers, we actually make use of WebRTC for making peer-to-peer connections between browsers, and then we fall back to a WebSocket-based proxy, which actually acts as a proxy to the rest of the regular peer-to-peer network. So essentially, we'll try to discover browser peers, try to connect to them over WebRTC, and then if we don't find them, or after we find them, we want to look for updates, we'll basically ask the proxy server to try to discover peers on our behalf, and then kind of multiplex those connections over the WebSocket.
One question.
So, yep.
So basically, in a normal browser, or in a mainstream browser like Firefox or Chrome, if I don't have the proxy server that gives me access, but maybe somebody has Beaker browser and visits the same web page, I could connect to the Beaker browser via WebRTC, and that Beaker browser could forward the traffic because he speaks all that stuff natively.
So at the moment, the way the SDK works is if it's running in Beaker, it won't actually try to do any of the WebRTC stuff because it doesn't have access to the lower level, like peer-to-peer API Docker's code, but that is something that could potentially be possible. Yeah, that's kind of like a difficult use case to support.
No, all right. Let's just
By default, it tries to use Beaker's fully peer-to-peer stuff if it can, and then it tries to connect to a local proxy if one exists. So say you have the DAT store command line running on your computer, it'll use that before reaching out to the internet, and then it'll be like a truly local first approach to finding peers. And then if it can't find that, it'll try to connect to the default gateway, the default proxy server I set up, or whatever one your application has configured. Yeah.
So basically, like mainstream browsers, they can connect into this WebRTC swarm and share data, but they still need one or multiple proxies to get the data in the first place. Like a Beaker browser, a running Beaker browser on the same website cannot replace that currently.
Yeah.
Okay.
Currently, no. Yeah, at the moment. Maybe someday. I mean, hopefully, one thing I'd like to see is just browser extensions for DAT and making that whole thing easier. There's been some progress, but sadly, getting distributed web stuff into browsers isn't really a priority for either Google or Firefox. So that kind of sucks. And they're the only ones really innovating in this space. I think Brave has some potential, but even then, they're just using Chromium, and they're just going off of whatever Chromium extensions provide them. I'm pretty sure the IPFS integration for Brave, because they've got a pretty decent extension, it also makes use of proxy servers, because we just don't have the peer-to-peer APIs available to us. Yeah, but basically all that to say, if you want to build applications with that, use the SDK, and then you can do stuff in Node.js in the browser or Beaker, and it all more or less works if you're lucky. So lastly, there's some cool projects building off of that. There's the command line interface I showed off earlier. There's the Beaker browser. There's Clicks, which is a Firefox-based web browser focused on privacy. And so they actually are working on a web extension that uses experimental Firefox APIs. And they have some of the functionality of Beaker, but it's a little bit more experimental, and they don't have authoring tools. There's the Cabal ecosystem, which kind of uses the append-only log portion of that for doing decentralized chat, which is super cool. Definitely check that out. There's Pushpin, which is like a collaborative pin board thing for project management and sort of like a Trello alternative that's fully decentralized, which is pretty cool. There's, of course, the Play project for distributing smart contracts at smartcontracts.code, which is super cool, and it's making use of some of these primitives. And then there's a bunch of other little projects in the community also kind of building with the primitives. So do check them out. Check out the DAT website. And thank you very much. Feel free to ask questions or whatever else. So, yeah.
We actually have, after you, Notal joining us to tell us a bit more about the Cabal chat. So we're going to dive more into that. Anyone having any questions? I mean, this was like a nice overview, so I have. Okay, so there is.
I was just wondering, like, what would you say is sort of the other projects that sort of overlap with this that are interesting?
So obviously IPFS is probably the big one. They also do peer-to-peer file transfer, but their approach is completely different from DAT. So whereas DAT is based on append-only logs and efficient exchanging data about what the latest files are in an archive and efficiently downloading chunks of data. IPFS focuses on deduplication of content across the network. So the way they do that is instead of having like an archive that contains data, every single piece of data is advertised individually on the network. So say I have two websites, they both have the same file. Those files are being advertised on the same swarm, and those two websites are sharing peers for those files. So this makes it a little bit more efficient for it makes it a little bit more resilient for discovering peers for a given piece of data, but it's at the expense of having to do a lot more advertising on the network and doing a lot more computation to actually discover which data a peer has and doesn't have. So IPFS, pretty big thing. Made Safe, they're in Scotland. They also do peer-to-peer file transfer. I don't know too much about their details, to be honest, but it's all so. Pardon?
They've been around since like 2014. I don't know if they've
Yeah.
done anything. They have their own
They're
token.
still alive.
Okay.
ZeroNets is pretty cool. I don't remember the details of how it works. It was pretty popular recently because it was in the news. There's some other just like little experiments. Obviously, BitTorrents, super cool. It's the OG. One cool thing about BitTorrent is it's super stable, and they've actually got a whole bunch of cool extensions in the BitTorrent like open source organization, not BitTorrent, the legal entity, which is now some crypto thing. Yeah.
Space and time.
Oh my god, what the fuck is that?
Yeah. But BitTorrent, the protocol, is awesome, and WebTorrent is a cool implementation of it. I think, if anything, if you're interested in designing these systems, just learn how BitTorrent works under the hood. Maybe even like implement your own BitTorrent client if you're brave enough. And then that'll give you an introduction into distributed hash tables, content addressability, like getting through peer-to-peer networks using hole punching techniques, and like why is UTP useful. It's just a general great building block. But I'd say the main project to check out other than that is probably IPFS. Yeah.
You wanted to ask something, Alex?
How stable or developed are implementations of that in other languages like Python, Rust, C++, and so on? Can I use them already, or I don't know?
There's no other functioning version of that other than the JavaScript implementation.
So they're work in progress.
Yeah, they're all works in progress. I have no clue how far the C++ implementation got. I think the Python implementation just started, I don't know, like a couple months ago, and Decentralized has been slowly working on that. The Rust implementation, I think they got so far as being able to load and save the actual on-disk format of the append-only logs, which is pretty cool. I think the Rust development is partially stalled because the person working on it is working on Rust's async primitives, like in the language.
Yeah, right.
I think he's working on the streaming for Rust. And I think a big portion is there's no funding for any of these things.
Yeah.
So people work on it in their spare time when they can.
Yes, it takes time. Sure.
Did you want to say something? No?
No, I'm curious about the funding. So you guys are working benevolently. Are you looking at, did you have like Patreon page or some way to raise funding?
Yeah, so we have an open collective for the DAT Foundation. There's not that much traffic there. Mainly the funding comes from grants. So basically, the DAT Foundation is a group that's underneath this larger group called Code for Science and Society. And so that's a nonprofit in the United States, which it acts as a fiscal sponsor. So Code for Science and Society will help write up grants or grant proposals and send them out and make networking and stuff to kind of like develop features for dApps. And then they kind of accept the grant funding because the grant givers can get like tax incentives for it. And then that funding goes into development of the protocol. I think there's also other groups outside of the dApp Foundation that have gotten funding. For instance, right now, a lot of the development on the new file system abstraction and the new version of the protocol is being funded by the Samsung Next grant, and that's primarily going to Andrew Osh. He's really cool. Shout outs to Andrew. Yeah, so there's not so much direct funding from people. We also got a donation from the Play Project folks, so big thank yous. And Wireline.
So in comparison, I was reading that the IPFS is like 300 million in funding. Meanwhile, you guys are all benevolent driven, which is pretty awesome to see you guys go head to head. By the way,
yeah,
I think you guys were there in Taipei like last month, and there was a talk about IPFS. Did you guys go to this one?
We didn't go to the next. Yeah, we were at the conference, but didn't go to the special.
IPFS talk. In it, I forgot the details, but when you were talking about the recovery, I was under the impression that the IPFS method to do it was the same, where the pointer was always pointing at the same place, but then like specific blocks of data, only the changing ones were the ones substituted. So it's weird to try to figure out like how they are different, IPFS and that. I mean,
yeah. So the main difference there is, I'm pretty sure IPFS is still using just a straight up Merkle DAG. So basically a tree of pointers to like blocks. So I have a folder. My folder is essentially a name along with a list of hashes of other folder data blocks. And that's kind of how they do the updates, because if I update one folder, I now need to update the parents and so on and so forth until I get a new head. Whereas DAT's file system abstraction, it uses a different data structure, which doesn't need entire hashes for identifying folders for one. I'd recommend reading up on hash array mapped trees because they are complicated and there are arrays of bit fields and like crazy crap that I don't feel qualified to talk about. But that is fundamentally different from having a Merkle DAG with links encoded to with links that point to hashes, which is what IPFS and more specifically IPLD is based around.
So does that mean like if you want to download a particular file from IPFS and there's like an entire folder structure, like the files is the atomic thing that you can download? Like
well, you download the folders as well. Folders are just
all right, but like
files.
if I have like a data entry that gives me like the hashes for all the files and folders inside that folder, maybe I can just get the metadata for that folder and then basically only load the hash for that next folder and so on, and then I don't need to download the entire folder with all its subfolders, but I just in the end download that particular file. But always the hash is like the atomic thing that I can access. While with that, if I have, for example, only a single file, could be, for example, the image to install an operating system, like a Linux image, and then basically I start installing, but I actually download only the parts from that image, like chunk by chunk of what I actually need without being limited to, like basically even parts of a file if I want only parts of a file, but in IPFS you always need at least the entire files. You
don't necessarily need the entire files because I think they also do chunking, where they take a file and they split it up into chunks. And then those chunks are like its own Merkle DAG. And then you can download subsets of that. But yeah, that's exactly it. You download things as you traverse the Merkle DAG.
Is it then in practice similar, like regarding the result?
It's very similar regarding the results, but the actual mechanism is still very different. partially because in DAT, we kind of have all of the data in one place, and we know where to get the actual data from the files and where to get the actual metadata. It's all from your peer, and it's all in the append-only logs. Whereas with IPFS, when you're traversing, every time you look up a block, you're essentially either like trying to ask your existing peers, but also reaching out to the peer-to-peer network and querying the DHT. And it's just a lot more chatty.
Okay.
But deduplication though. So if I have two folder trees that are exactly the same folders, those are fully deduplicated, which is really cool. Yeah. But yeah, regarding funding, the funding model does make a difference to me at least, because IPFS is mainly owned by venture capital and by people with lots of money that just care about making lots of money. And at some point, IPFS is going to have to make lots and lots of money for some very wealthy people. Whereas DAT, we just receive grants, and once we get the grant, there's no strings attached. We're not beholden to any investors. So it's another trade-off that's not really protocol related, which I think is still relevant to a lot of use cases.
Yeah, I agree. I mean, because there is no free lunch, you know, you can get VC money and it sounds like, yay, they're supporting me, but they expect returns. So what these returns will be? Yeah. I mean, they have to then at the end start monetizing, and then I don't know, they will charge for the protocol use, or I don't know. I mean, at the end, they, you know, and then once you get hooked and you buy into the system and you build everything on top of this system, and then they start charging. Not good.
Well, I'm guessing Filecoin is like their biggest thing. So like if they get Filecoin figured out, then they'll make money off of that somehow, I assume. I don't know. Or crypto
We
stuff.
might be faster though.
We might be faster, but we will not make anyone else rich.
Yeah.
With that dot, we will basically just make the system work.
Yeah, one goal I have is just to like remove the whole need for money in these systems. Like I should be able to share files with people for essentially free. I should be sharing resources with my friends so that we don't have to pay some capitalist in order to do it, which I mean, obviously is not something everyone is interested in, but I think ultimately it'll be more resilient because you can't compete with free if it works. And then we can focus on like spending money on things that actually matter, which is like, you know, food, housing, and then eventually try to figure out how to make those free so that we can just like say, you know, like buy to money in general. But that's like long term.
I mean, we have to figure out somehow how to work peer-to-peer in all aspects, also in economy, somehow without taking all the profits away from us. So, yeah, I agree. Any questions, guys? I don't know. Do we have Nofel in? We have another person.
Yeah, I saw her in there.
Yeah, is this Nofel?
He's muted, or she, whoever.
Yay.
Yeah, right, okay.
Is that you, Nofel? Yoo-hoo!
Hey, cool. Nice to see you.
Hey friends.
If Mov, I mean, if you want to stay with us, I mean, you can of course do it. But otherwise, I would just like to thank you for staying up so long and to get us introduced into the DAT world.
Awesome, thank you so much. Hopefully this overview is helpful, and hopefully it'll help Kira's whatever she's going to be presenting to. I'd love to stay, but it is 3:20.
Very late, yeah.
So thank you so much. Good luck on your talk, by the way.
Thank you. Thank you. See you. Bye-bye.
All right, good friends.
Yo yo. Yay.
Oh,
Hey.
Hi. Hi everyone.
Yeah.
Is there like
Yeah, I
Is there
did Jitsi will
like
work for us?
a share screen feature on this
There,
app?
there should be, yes. There should be a button in the lower
Next to the
right.
hand, I think, on the left
Yeah.
bottom.
But it might ask you to install an extension eventually.
Otherwise, we can just move to also to Zoom or
Yeah.
something else.
Usually it works fine, but I think it requires an extension, but that should
Does it require anything from you? If you click, what happens?
I don't see a button for it.
Ah.
So bottom left,
left, yeah, bottom left.
where
Bottom
some
left.
hands.
Ah, sorry.
Are you said right?
I think I mixed up left and right a lot. I'm sorry.
Yeah, it wants a web like a extension.
Okay.
Ah, okay.
So
I can do it. If you guys have time, I can
Yeah,
keep
no
messing
problem.
around with
yeah,
this.
but honestly, if you have Zoom, because Alex doesn't have an account, maybe
Oh, but
you
I'm
can
sharing
just.
already, then we don't need to set up. I mean, the extension should be fast.
Oh, yeah, okay. Should be.
Yeah, usually that goes fast with the extension. And if it doesn't work, we can switch. But
Okay.
it's,
Yeah, because you're streaming. Then
yeah, then I have to change everything. That's even more.
Then maybe if you could do that, that would be
Yeah.
super nice. The extension, right?
Yeah, the extension. Maybe we're lucky and it works.
Can we ask you to install the extension?
I'm installing it right now. One
Oh,
second.
okay. So,
All right.
I mean, it's hard, because everybody has their preferences, and Mauve was like, I don't know, I don't want the Google Hangout, and then this one is kind of something that usually you just don't have to have an account, but obviously you need to have an extension. So, shit, nothing is free.
Does it work?
Uh-huh,
Yes, yes, I can see the screen.
Yes.
Perfect. Lovely.
So
You see,
I'm gonna rotate the
Yes, perfect.
Yeah, I
computer a
can see.
little bit so that you can also see us.
I can see. Yeah, that's great. It's just like a Jitsi watermark thing, but like it's still fine. It's big enough. Yes, very much.
Yay.
Awesome.
Oh, that's good font.
Cool. Okay.
I'm not
So,
sure. All right.
I'm novel, and I guess so. My background is that I'm working on peer-to-peer technology in JavaScript for the last like 3 or 4 years. I've worked on. I got started just sort of messing around in like the Node.js community. Then I worked for IPFS for maybe half a year. And then I got involved with that and Secure Scuttlebutt. I don't know if Secure Scuttlebutt has come up or not. And more recently, I got involved with Digital Democracy. And they work on this open source peer-to-peer collaborative mapping application called Mapeo. And it's both it's like a desktop and mobile app, and it's being used by indigenous communities in the global south to do both territory marking for like legal land rights, as well as ecological monitoring for things like illegal oil drilling and gold mining and things of that nature. And Mapeo is powered by DAT. Kind of. It's powered by DAT, kind of, because that's actually made up of like several pieces. Like there's DAT at the top, but then there's DAT at the top, DAT at the top, and then underneath that there's like something called Hyperdrive, which models a peer-to-peer file system, and there's something eventually somewhere down here named Hypercore, and Hypercore is just a like pretty low-level piece. It's kind of like a database, except it's like a database that only one person can write to, and you can only write to the end of it. It's like an append-only log, and it can also sync itself between peers. So Hypercore is the part that me and some of our folks pulled out and built into something called Kappa, or KappaDB.
And so this sort of and it's just sort of a different way of writing peer-to-peer apps compared to so the data approach is like file system based, and instead this is sort of built the idea with KappaDB is around collaborative applications with multiple writers. And one such example of that is called, that I'm working on with some friends, is called Cabal. So I haven't met any of you. I have no idea where you're at or if this even makes sense or not. I'm just rolling. Cabal is a peer-to-peer chat platform. The idea was to kind of like IRC is pretty good, and Slack has like a pretty nice interface. So the idea was like, how to make something that's peer-to-peer, but has this nice, sort of like Slack-like interface and Slack-like experience. But it's all like peer-to-peer, no servers, open source, works offline, and like all these like really desirable qualities. And that's kind of what we've been building with Cabal. And I'm going to quickly demo that and sort of just like talk about it as I demo it. Is this size okay, or is this too small?
Yeah.
Totally.
Makes sense. Works.
I see. Yeah.
Okay, I'll take it big. So there's the desktop application, which is like this one. It's called Cabal Desktop. And there's also a command line application that's just called Cabal. And whoa, okay, I might need to make the screen a bit smaller to make it fit. Here we are. So you have this like retro, like 90s kind of like command line interface. This is the public Cabal, which and a Cabal is identified by a 32-byte key, a public key. At the top right corner, you'll probably see this like long like string here. And this uniquely identifies the Cabal. What's cool about that is that this key is used for both discovering peers on the network, so finding other people to chat to, and it's also used as an encryption key. So if someone peers with you and says, oh yeah, I'm totally interested in this Cabal, they would have to encrypt their traffic with this key in order to like prove that. So just with this one key and passing that around is enough to grant entry to this particular Cabal. And you'll see over here, Nick Warner's highlighted now, and I'm peered directly with him. And so what happens is Nick has an append-only log that he writes to of chat messages, and so do I. And then whenever we peer with someone, I get all of Nick's peers, all of Nick's append-only logs, and I share with him all of my append-only logs. And if we pop open the hood and just look at these append-only logs on disk for this particular Cabal, it's just a directory full of other directories. And each one of these numbers is actually a hypercore, an append-only log. So if I open the 0th one, I can like look at this file called key, and this will actually print out my public key. So this key actually refers to me on this particular Cabal. And I can also cat the data file, which is literally just like JSON, like new line delimited JSON of every chat message I've sent. I can pass this through JQ to get nicer output. JQ is a really cool program for parsing JSON. So you can see that every message I've written is here. And each message has a type. It has a channel that it's written to, and just text. And since anyone can post whatever they want to their append-only log, you can even invent message types that like no one's even using yet. In fact, I wonder if we could quickly see a tally of all the message types. Like data, and then
can you click hide on this banner?
Sorry?
Yeah, we're saying on your screen the GT meeting is sharing your screen with meet.jt.
Like a banner, you can even click the hide and then the screen goes away.
Oh, I'm sorry. I didn't notice that.
Yeah, it was hiding what you typed, but it's fine. I think.
Oh,
But
it didn't go away?
it
No?
doesn't go away?
I'm clicking on hide, but it's
Oh,
like,
shit. Okay.
it's
it
not
doesn't
fine.
matter.
Just Control L to clear your screen.
yeah.
Oh.
All right, yeah, that works too.
Okay, I'll try to not go to like the bottom of the screen. Yeah, so there's just sort of this, this very flat directory of every hypercore. And if someone joins the Cabal, there'll be a new folder here, and it will have whatever data they've written. But unique to the zeroth folder, which is my core, there's also a secret key folder that the others don't have, which has my secret key. And that's what lets me append to my log. And since I don't have anyone else's secret key, I can't write to the end of their log. So everyone else's feed is read-only, and mine is read-write.
Because this is how hypercores work, right?
Say again?
This is how hypercores work.
Yes.
Yeah. So this is a secret key that basically
Yeah, when you
enables you to
add
write.
more data to your hypercore, you sign it.
Yeah.
Or you sign
And
the
this public key that you have in Cabal, is it like the same as the one that is generated for hypercore?
Yeah. It's just it's a 32-byte elliptic curve public key. And and it's just like a regular chat client, like notifications and all that junk.
So you're using it in the terminal, but you can also use it in the browser.
There's this stuff over here, which is an Electron client, so it's like a desktop app. Someone named Joe Hand once wrote a Cabal web client on Glitch, but it was just an experiment. It was kind of slow. I feel like the peer-to-peer scene for the browser is still kind of like not super great. So the code is all written in a way that definitely supports the browser. Like all the storage networking is generic. Like you could use it in the browser, but just no one's written like a nice browser client yet. So
basically, it needs this SDK like this. What Mov did for that kind of.
I'm sorry. Could you repeat that again?
So it needs like an SDK, like something like what Mov built for that, for hyperdrives.
Kind of. Well, so there's a module that Alexander wrote. He's one of the core devs, named Cabal, a high-level interface for writing clients for Cabal, like the desktop app and the command line app both use this, and it just sort of gives just a high-level kind of API for dealing with like channel management and names and sending messages and all that kind of stuff.
Does it mean if I copy paste the example from the README that I get my basic Cabal client?
This particular example it creates a Cabal, but it doesn't actually do anything with it.
All right.
You'd probably be better off looking at like Cabal CLI repo to see how it actually like uses the API to do a client.
Oh, okay. Cool.
Yeah.
Does anybody have any questions? Okay. Do you have any questions, Alex?
No, fine.
Do you have something else to show us?
No, not really.
I have. We've been now playing around with the hyperdrive, and we figured out that we actually need the key value store to be able to access data faster and like to not have to like, because we have a folder with a lot of contracts, smart contracts in, and now each time we want to load them in the browser, we have to first patch all the addresses, all the paths, and then we can kind of load them in the browser. But with Hypertry, we can basically get them one by one and display them as, I mean, we can create a stream. So I wasn't aware before that KapaDB is also like a key value store. So just for me, I would like to understand what is the difference, because they are both kind of built on top of Hypercore, right?
Yeah, well, Hypertry is a key value store. Capcore is really, it's just a way to process messages like from the append only log into these into views, into basically like tables or like, and basically any data format. Like there's like a module called Kappa View KV, which models a KV store over a set of append only logs. But then there's also things like there's a spatial database view that takes geospatial points and lines and creates a spatial query database. So Kappa isn't limited to like just being a KV store or just being a spatial database. You can create any kind of like way to model that like log data that you want.
And Mapeo, I mean, these peer-to-peer maps, they are using Kappa.
How do you spell kappa?
Kappa.
Oh, okay. Like the Greek letter.
Kappa. How are you funding your project? Is it completely like volunteer-based, or do you have any funding?
For Cabal or Mapeo?
Oh, for Cabal.
Cabal has no funding yet, but we're working on like grant applications and stuff. It's really just been like spare time labor over the last year.
And
We all
Kappa
really want
also.
like a free alternative to Slack that will last forever.
Yeah. And Kappa also. So everything was done basically for free.
I had a lot of funding support from Digital Democracy when building Kappa because we wanted to change Mapeo to use it. So I had support building the initial versions.
That's nice. So basically, yeah, because we're also here like learning or exploring what are ways to fund your open source work.
Right.
So basically, finding a project that will use your technology is one way, obviously, to develop it. So they use it, and that's why they kind of also support you to build it.
Right. Yeah, it's really hard. I feel like I had spent a lot of time in like this particular like area to like become known enough to get like work. It's tough, but like it feels like there's more and more interest being put. So hopefully the money pool will keep on increasing.
Yeah.
But it still sucks.
I mean, I know that in the blockchain world there is a lot of money, and they have a problem with storage. So hopefully this opens some new options for this kind of systems. We are just trying to spread the word and hopefully popularize the field and to use it, of course.
Awesome.
Yeah.
Yeah.
And to use it. Yeah.
What do we do next? Any questions? Anyone? Anything? I think like because like for most of the people here, this is like completely new. I mean, they are developers, but like, is it? Yeah. So now we probably have to digest a little bit the things.
Yeah, no worries.
Could you tell us a little bit about why you, was there a thought process to why you chose Kappa versus other options?
Yeah. So at the time, kind of the only options were like IPFS or DAT, really. Scalable's a thing, but it's not really optimized around like real time. Yeah, there's like yes, there were trade-offs. Initially, I was going to use something called HyperDB, which was a experiment team was doing to make like a key value like peer-to-peer database. A lot like LevelDB, like our any kind of key value store, but peer-to-peer. And that ended up not really going in a, like, the approach that they were taking and that takes today is data isn't stored in the hypercore just like as it is, like I was showing you with Cabal, like the chat messages were stored as is in the hypercore. With that, it's the key value index data, like the tri-structure index is stored like alongside the messages. So like it kind of means that all the information to do key value lookups effectively is built into the actual like data structure being written to the peer-to-peer database. But with Kappa, you just store the raw log data, and then each peer is responsible for passing these log messages through these views that index them and turn them into like a key value store, a spatial database, a back references lookup table, kind of whatever you want. And having just the key value store, like Hyperdrive does, didn't give enough sort of flexibility to turn this log data into like potentially many different kinds of databases. And nobody else is really doing this. So like, there's like log databases, like Apache has some stuff. Kafka is one of them, but none of them are built around like peer-to-peer. It's all sort of like this like client-server architecture or like heavier like cloud infrastructure assumptions.
If we want to try out Cabal, how do we get started? If we want to start using it.
A new one?
If you want to start using it as a community, how do we get started? What would be, do we like install it through the command line or?
Right. Yeah, let me share again.
Or maybe you could also use the Electron app.
I don't know.
Or probably even choose if it's either or.
I mean, Electron app you have to run, but terminal is there.
Yeah.
And it looks
yeah, so they both work. I mean, for desktop, you just click on Cabal Desktop and you'll get taken to the releases page. And you can click on the download link for whatever your platform is. And it's just like an executable file. If you want to install the command line version and already have Node installed, you can just type in npm install globally Cabal.
And then npm install and npm start.
I'm sorry?
You just get up Cabal.
Yeah, true. You don't run it in the browser.
Yeah. And then how are the your peers? How do your peers access your sort of your server?
How do you find the people?
So you are,
Yeah,
that's why you share
that's a good question.
about that link, right? The 22-byte.
Well, you have to like make your computer accessible to the outside somehow, right?
Right. So did my video go away?
The screen share. I mean, sharing is stopped.
Oh yeah, I thought I turned the screen share off. Oh, here.
Again,
Okay, so discovery. So one of the challenges with peer-to-peer networks, people are running laptops that are behind firewalls or NATs, and that makes it really hard because if all of you are on the same Wi-Fi right now, your public IP is probably the same, but your internal IPs are different. So that's one challenge. One easy way to get around that is by having like one person at least be on like a public IP. Like I have Cabal running on my my virtual private server for like the public Cabal, and that lets my server act as kind of like a relay for peers that don't have the ability to like be connected to from other external people. And this like relaying property comes for free because if you connect to me and send me like all your chat messages and I'm connected to someone else, all the logs are always trying to be up to date and sync. So any new entries you pass to me, I automatically share with anyone else I'm connected to. So often having just one person in the Cabal with an accessible computer can help link up everybody else.
I kind of get that.
This is like a pub in SSD?
Kind of, except there's no invites.
But how do I initially, like if we, okay, I put one instance on a server, but how do other people find me? Like,
Right, so discovery is automatic. So it's a combination of either a like discovery server or the BitTorrent distributed hash. So everyone is just swarming around the topic of the topic string, which is that Cabal key. So as long as you know that key, you'll be able to use like signaling servers and like other peer-to-peer networks to locate people also interested in that key. Duration. Two people just run Cabal with the same key and they should find each other.
and if I want to now connect with you, for example,
Could we try that?
can we try it?
Yeah, let's do it.
Then Alex, try
No, I'm streaming,
Oh,
but
yeah.
you can use
Or
your terminal.
can somebody else do it? Do you want to try?
If you're streaming, you should be able to screen.
Yeah, I can.
Show the monitor. Show the.
Okay, maybe I can.
Yeah, I'm just
try.
wondering what happens. Yeah, right. If I'm doing this, it would be in the stream. That's actually not bad, right?
Then Alex will do it. Yeah.
All right, I will try. Let's see.
Make sure that you're sharing the screen.
Yeah, I guess I do, no?
So
Is this Alex's screen? No, that's not us.
Oh, that's not
Alex, can you try sharing your screen?
All right, yes, I also share. Okay, let me try. I hope that doesn't mess up everything.
Can you see Alex's screen?
yes,
Okay.
I mean I can.
We also can.
Okay.
Okay, so
You need to
how
move away from the-
can I give you this Cabal key?
9. How do we-
Okay, copy it in Jitsi. Jitsi has a chat.
Oh, okay, where? I don't know anything of that.
Is it this one?
There's a chat on the right side of the house.
Oh, I see it.
Yeah,
I see it. Okay.
Horrible. Their UX is like, oh my god. But it's free, so I don't
So
know.
what is the command to join a room?
Instead of clicking on this, go back.
This one?
What do you mean, go back?
You can select which screen you're sharing. Right on the background.
So I stopped the screen sharing for a
No,
second.
no. Keep your screen sharing, but stop
Okay,
clicking your
I
camera.
posted it.
So like this.
Ignore the emoticon. You can just copy the 9E15 string. And then you'll
I need to see the key. And also maybe then people can also see in parallel what are the ways of happening.
Yeah, can you copy this?
Ideally.
So is it Cabal -- seed and then the string?
So I copy this one.
So dash seed is only if you want to not show a user interface. It's for like running it headless.
Okay. So what is?
Every peer is actually a seed always.
I don't know. What is the command to join then? Oh, it's just.
Is it like this?
Yeah. Yep, you got it.
Let me try that. Oh. Oh no. Windows is horrible.
Oh shit.
How do I fix that?
Yeah.
Security exception. Is it a firewall thing maybe?
Shit.
Is it?
Does someone have a Linux machine they can try that?
Yeah. It's the same.
Alex, can you
Mac
share
OS?
this key with Jonathan because he's trying
Oh yeah. Wait, I can copy paste you the key somewhere.
Let me see if I can get it.
I can do it in Telegram and
Yeah, put it
WizardAmigos.
on Telegram. Oh.
Because I know this is for a story to retype the whole hash.
Okay, here you go.
Because maybe then we can replace Telegram.
Yeah.
Can you put it in this other chat too? What is it?
Gitter. Yeah, I can do it on Gitter too.
Some people do.
Yeah, let's use Gitter to bootstrap Cabal.
So I'll put it on the WizardAmigos channel. All right.
So now people will try to decode what this hash is for.
So let's see. Maybe I can even fix my thing.
If I try to open that,
Maybe I
with
install it
this
locally.
hash in Beaker, it wouldn't work, right? No, because it's not a
No,
hypercore.
it doesn't use the same format. It doesn't use a hyperdrive like
Yeah.
that assumes. Oh, I see 2 people joined.
That's me.
Oh wow! So it worked. So you can say something.
Really, we have 2 people already.
I believe it when I see a message.
So wait, Alex,
know how
does
to
that mean
send a
that
message.
Windows is?
No, I will not try to install it locally and use npm start script.
But how did you
Maybe
join
that will
it?
work and get
How
around
did you
this
join?
Windows
Through command line?
limitations.
Really? Linux, and you are on Linux.
I don't know how to send a message though.
Okay.
Is there, like, yeah, I don't know either.
How do you send a message, Noto?
Oh, just type it in. Just type words and hit enter. But you need to join the default. You need to like join the default channel.
How do I do that?
Type in /join space default enter.
Like IRC kind of style.
Yeah.
Oh,
Yes, that got me around it. Awesome.
How do you set your name?
/join? What do I do? Join what?
No, /join default. Yeah.
Join default.
Yes.
This is pretty cool. Is this is the UI or the TUI done with like N curses or blessed? Do you know?
Sorry, can you say it again, please?
Is the text user interface, is that done with N curses or blessed?
I see. It's a higher level library that does a React sort of interface called Diffie, but it uses like N curses like deep down.
Oh yeah, there's a nice video from Macintosh where he shows Diffie and how it works. I think I have that somewhere. That's a really cool one. Yeah.
What is this? Diffie?
A module that helps you with doing command line interfaces. I like it.
It's
Cool basic
you
building
basically,
block.
it's kind of like React. Like you give it like a terminal screen of text, and it diffs it with what you displayed on the screen last, so it doesn't need to redraw the entire terminal window.
It efficiently updates the terminal screen.
This I was watching this when it's changing the clock.
Yes,
kind of,
yes, like he was doing a nice video. But I think I didn't join. Like I have my. Can you see my screen shared? My shared screen? Maybe I joined the wrong channel. But why? I said join default, but something didn't work. I guess.
Awesome.
Did I do something wrong?
Make the window slightly bigger, and it'll show you the side.
Are you saying that it might already work? Wait, maybe if I do this. Oh, okay. I'm kind of alone here.
Yeah, you're right.
Yeah, I would
say
say you haven't connected to anyone. Try killing it and then Control C and then running the command again. Yeah.
I mean,
maybe there's a firewall thing happening.
All right.
Did you also?
Because just because my Windows kind of doesn't allow me to run the command like directly, so I'm just using npm instead, and it seems to work, but I obviously can't connect. Firewall.
Yeah, it looks like you're not peering with us.
I see. Turn on account protection. I don't know. Firewall network. No action needed. Maybe I can turn that off.
Oh, I saw. I think. Oh, no, I was seeing my window. Never mind. I'm not sure.
Oh wait, no, there's stuff going on. Welcome to Cabal. Does that mean I connected somewhere because it says welcome?
Oh no, that should appear instantly. Maybe it's just really slow for some reason.
Okay, maybe firewall is on, private network. Should I maybe just turn it off?
Yeah,
Virus is all the way down.
Yeah. I mean,
YOLO.
I don't care about my system anyway.
It's
It's just temporary anyway. So did I not turn off everything? App browser control, I don't know. Can I turn off all this stuff? Let me just try again. Maybe that already did it. Maybe not. Fuck Windows. I so want to use it.
Okay, I don't know, Nofo, are you?
Okay, maybe it doesn't.
Are you
work
very
for me.
tired already? Because there is also like 1 o'clock, right?
Well, at least it worked for others, so I guess I would just switch and somehow it will work for me too.
Yeah, we don't have to debug it right now.
Yeah.
But in general, if one person, usually the connectivity just works unless you have like a really restrictive like network workers sort of thing.
Obviously, 2 people managed to join. I have this camera on
Yeah.
now, so I'll try later. But that means that we are all
Yeah.
in one chat room. Or can you make like your own little world, or is just
Yeah,
this?
you can make however many cabals you want. You just type in cabal -- new, and it just makes a new one. And if you don't tell the key to anybody, nobody can ever join.
So one question, that means like every cabal address is exactly one channel.
Yes.
No,
No.
you can make as many channels as you want.
So also for the same one, I can make like some sub rooms or I don't know.
Let's see.
Yeah, the channels are just arbitrary. So
Okay, so basically also on that channel you
How
could
do you
just
create
make a new room.
channel? This one?
/ join and then channel name.
Ah, okay. So instead of default, you join something else. You make it up.
Wow.
Yeah,
That's awesome.
make it up.
That's awesome.
Wow. Okay, so I see this is gonna be fun.
Yeah, that's
Cool.
awesome.
Does
We need to-
anybody have any questions for Nofel? Because I think he would maybe want to go to bed.
So,
No, beautiful.
it's really cool. Yeah, we'll definitely play around with this.
Yay.
Cool. Thanks for having me. Good seeing you all.
Thank you very
Yeah,
much.
thank you very much. This was really cool. Thank you.
Okay, then we see you in Cabal. I
Yeah.
guess.
Yeah.
Yeah,
All right.
I'm online
Yay.
for free.
That's
Perfect.
cool.
All right.
Okay. So now I can Joshua and tell him, because Joshua will go next.
Oh,
Tell us- That's really cool.
How can I?
I
Because
didn't expect
I'm
it
live
so easy,
streaming.
because usually it's like. And now imagine this works offline, so we can kind of, you go on a plane, you're, I don't know, without internet for like, I don't know, hours, but you can still probably see the history of all the chats and everything. But, like on Facebook, if I try to open it, when I don't have internet, it's nothing. It just doesn't open. And here you can go and like.
Can you use it? Because I'm on the live stream, so whatever I do, it's like live streamed.
So I can ping, what's Joshua?
Yeah.
Wait, Joshua.
And also check if maybe Kaosat or.
Yeah, I sent him already the link.
All right.
No, where's Joshua? Joshua. We're in
It's awesome to display name.
meet the
Change
Jacob.
my display name to be.
Jacob SI/WizardAmigos.
Is there an-
Well.
Oh yeah, my name is red, and yours is yellow.
You changed the name to Bao, huh?
Yeah, because I can,
Exactly.
which is not a good thing. It would be good to have like your.
I think you can register. I saw it already.
Yeah. It'd be good to have like, because I assume that's from my public key address. It'd be good to show like a short version of it, so it'd be easy to differentiate from nicknames.
Okay, we have Joshua in 5 minutes. He will share a little bit, because these DATs, if you create your DAT, like this what Mo was sharing before, how do you keep it alive?
Yeah, there's like 3 ways. 2 are covered easily. One is like if you have friends who do that, who pin your data, then it's of course available. Another one is if you have like Wikipedia kind of data and many people are interested, they share for free because they're interested in the data. But if you want to keep something online that nobody's interested in and you don't have any friends who would just give you arbitrary space, then maybe you want somebody to pay for that. That's getting pinned. And that's kind of the use case that we're trying to solve. And I think Joshua will talk a little bit about it.
Excited by this stuff.
Yeah.
So awesome. Just gonna keep up in.
Yeah.
Perfect.
And it's all using the same thing as the talk before. The file system works on the same core technology. So, and there's more examples. And this, yeah. So that's really powerful.
I was just setting up IRC 2 days ago and had to register on Freenode over it, and I left some channels and I showed my IP address and I was completely fucked.
Yeah.
I don't know how to do IRC. Like, I'd be interested to try it, but
Yeah, but I already got enough from that.
Yeah.
This one just popped in. I mean
Yes.
with IRC too, but
Yes.
why do you leave the rooms? Use your IP address.
There's even like another chat system also built on top of that. It's called Peer Links. And in theory, the person who built that should also join today and present it, but I'm not sure if he will. Because of the time zones and stuff, it might be messed up. But yeah,
No. What's it called? No, don't run this route. It's a problem with the pseudo.